guys, so welcome to the introduction to C. Let's do this. So C was created by Dennis Ritchie at the AT&T Bell Laboratories in 1972 as a successor to the B programming language. C is a low-level programming language, that is, there is little difference between C and machine language. C is also a compiled language. It is not interpreted, so you need to compile the files before you can execute them. C is also not object-oriented, and this is where it differs from C++. And so you should know C++ is an extension of the language C. So what do we need to work with C? The first thing is we need a terminal, which I know you all have, a command line. The command line commands, you should know how to use the commands lx, cd, pwd. Also, a text editor like vim or emacs to create a source file, and a compiler like GCC called GNU Compiler Collection. So, a simple program in C. Let's create one quickly. Our first C program. Okay, so I'm going to call this program hello. hello.c. Any file you create in C must have an extension of .c, all right? So enter, and let's begin. So I'm going to explain everything as I type them in. So the first thing you need to add inside of your C file is the header file. So I'll say include. So this is how you include the header file. And which header file are we importing? We are importing the standard input.output header file. Then it is important that you leave a comment. So my first function will be called main, so I will just write this here, and this prints hello precious. It's going to say hello to me, so your program can say hello to you too. And there will be a return value, and this returns 0. That's about it. That's the first comment. So that's a comment or a long comment in C. The next thing is, let's create our function. So this int is called the data type, and this stands for, this is an integer. So because my function is going to return 0, 0 is an integer, so that is why the data type int is right there. So int, the function name is main, and it accepts no parameter, so it's void. All right. So I'm going to open my brackets, and I'm going to do my printf. So you use printf to print messages to the output stream. All right. So I'm going to say hello precious, and our return is going to be 0, like we said previously. We are returning an integer 0. And that is it, your simple C program. All right. Now, there is something I want you to know, and that is the inline comments. You use this for inline comments, but this is not nice according to Betty. So with Betty, it's better you use this, the Betty comment style. This is the one Betty approves. So you use this, and we say inline comments. Okay, if you use something else, Betty is going to complain. So let Betty show you love. So I'm going to quit out of this, or let me pull out our presentation. So you see what I've done. The include statement is the preprocessor directive to find the header file, and the header file is the standard input.output header. Without this header, we can't use the printf statement. Now, these are comments in C. You use this for multi-line comments, or you use this for one-line comments, but like I said, it's not advisable to use this one with Betty. Then this is our first function, int main void. So this is the main function execution, and everything you do in C starts and ends with the main function. So the int here is the integer value, it stands for integer and is the data type. The main is the function type, and void is telling you that the function is accepting no parameter, okay, like we have here. Then /n stands for new line character, so it moves the cursor to the next line. So you will see why I would use it now. Let me use it here. So I'm going to put a new line here and type something else. So I could say something like hello to you too. So you will see why we are using the new line character. Printf, and I would say hello to you too. Okay. And we have our return 0. This ensures that the program runs successfully. So that is why we are returning 0. If we return any other value, it means the program did not run successfully. Alright? And exit, you use exit to jump out of the execution of the function. I've not used exit here, but I'm going to use it at a later time. So the first thing we need to now know is compilation. So how do we compile this file? Because like we said, the computer cannot understand this file the way it is right now. So for it to understand it, we have to compile it. But before we compile, let's ask Betty to check our file if the file is okay. And Betty says there's a problem, so let's go back and check. This is some things you need to check with Betty. Line 1. Okay, so I did not put this, I didn't put the hash symbol. I guess that should be the only problem we have. If not, we'll spend a lot of time here. So good, Betty has no problem with this file, so we can clear. Now compilation. To compile, you use what we call GCC. So if I say GCC version, this will tell me if I have it installed. So I have GCC installed on my computer, so I can compile my C files. Now, in the compilation of C files, there are 4 processes that takes place before the final process, which is called the linking. So all these 3 other processes, they happen automatically. So most times we just do GCC and we get our command. So I want you to understand what I'm going to do now. So I'm going to just say GCC hello so that you will understand it. So if I say GCC and the file we want to compile hello.c, okay, so let's redo this. Just GCC hello.c, and our file has been compiled. So if I do an ls, now let's run that file. I want to show you something. So you ./a.exe, so it could be a.out on your computer, and as you can see, hello precious, hello to you too. Now before all this happen, there are some intermediary steps that takes place, and that is what leads us to compilation in C. So the first step that takes place is called the pre-processing, and to see what happens when you do pre-processing, we have to use the flag /E. So let's do that. So GCC /E, and what file are we checking the pre-processing? hello.c, and let's send our output to something like hello.e. Okay, good. Now let's do an ls. So this file now, hello.e, is not the final compiled file. Instead, it is a preprocessed file. So let's see the content. Let's use less hello.e. And can you see there is just so much, and you may not even understand what is happening here. So our simple line of code that was just like, I think 14 or 15 line, has been broken down to all this. So what this is doing is it removes the comments, it looks for the header, and it also replaces all the macros. Okay, so this is the pre-processing stage, and to get to this stage you use GCC /E, the file name and the output. Now the next step is the compiling step, and we use the flag S to get to this step. Okay, so let's see what happens when we compile this file. So the compiling step does the pre-processing, and does the compiling together at once. So let's use /s. So let's say GCC / capital letter S for compiling hello.c, and let's put the output to be hello.s. So ls to see if it is there. So it is there. Now let's see the content of the hello.s file, the compiled file. Okay, so let's use less to do this again. And here you have it again. Now the file has been preprocessed, and now it has been compiled, it has been broken down. You can see the file name, our printf, you know, and every other thing that we have here. It has been broken down. Normally you won't even get to see this step. Okay, so now we've done two steps. We've preprocessed the file, okay, GCC flag E, and now we've compiled the file. The next step is for us to now send it into the assembly code. The assembly code, or the assembling, is the language that the computer actually understands, and we use /c to do that. So let's go, we say GCC /c, and what file? hello.c. to what output? Let's send this to hello. Okay, we have hello.c, so let's turn this to hello.o. Okay, hello.o is going to be the assembled file with the assembly language. Now let's check what is the content of this assembly stage. hello.o, that is the file name. So it's not telling you now that hello.o may be a binary file. Remember, binary is what the computer understands. So this is the stage that it turns to what the computer can understand. So let's see it anyway. So I say Y, and as you can see, a lot has changed. From the first stage, we understood it, but at this stage, we can't understand it anymore. It is the computer's turn to understand it. So we can't do anything with this file, so we quit. So now, we've been able to do the 3 stages of the compiling of a C file, and the last stage is the stage that we all are familiar with, okay? And that is the linking stage. So this stage is what links the assembly language file to the file that we created, so that the computer can be able to trace the file and interpret it. So let's now compile, let's link the file. So let's do all the process together, and we do it by saying GCC, okay, GCC so GCC hello.c, this needs no flag. Then previously, you know, when we compiled it, it sent it to a.exe or a.out. But now we can actually give it the name that we want. So we can say output it to a file called hello. Let's use exe. So this is going to be our final file. So now if we now do /hello.ese, this is the linking stage and the final step. As you can see, the computer now understands it, and now it prints out hello precious, hello to you too. So if we go back to check again, we've done these are the 4 stages of compilation, okay? Preprocessing, compiling, assembling, and linking, and these are the flags that you use for them. All right, so let me quickly show you what exit does before we continue. So for you to use exit, let's go back to edit the file. Exit is going to stop the execution of the code. So if I say exit right here, and I save this, previously without exit, the 2 printf worked. But when we use exit now, so let's compile. Oh, sorry. So before we can use exit, we need to import another header. Don't worry, you don't need to think much about this. So we have to include the standard library std to use exit, okay? So save, clear, and let's compile it. So now that I've compiled it, let's see what exit does. hello.exe. As you can see, because of exit, the second line did not run because we told it to exit. Immediately it does the first line. So it has exited after hello precious, and it didn't do this last line. So if I take out exit, our code is going to work the way it is supposed to work. So that is what exit does. Okay, so I'll also remove the header we put there so that we can return. All right, so let's recompile finally one last time and test it out. So you see all codes ran successfully. Good. So now you've been able to learn the 4 stages of file compilation in C. Okay, preprocessing, compiler, assembly, and the linker. Now the next thing you need to know is variable. So I'm not going to type all this out, or maybe we should, but I just want to be fast with this so I don't take much of your time. So to declare a variable, you use the data type and the variable name. So let's try that out. So using our file, let's declare some variables. To declare a variable, you say something like int. You use the variable name, x, that is declaration, and after declaration, you can now initialize, so s can become 25. Okay? Or you can do it once and for all, int y is equal to 30. So this is initializing and declaration at the same time of variables. Okay? So there are different types of variables. The same thing, you can just type it out on your computer. And int age, like we did here, is an integer, so you don't use apostrophe or quotes. There is a float that takes dot notation, so 3.45 for decimal, and there is a single character that takes a single quote, and you also have the array of character, which is a string. So you use this to write that, and you put your arrays inside of it. Okay, precious irreho, like I've done here. So let's see if we can quickly create all these variables. So we've done int. Let's do for float. So float z is equal to 34.67. Okay. Let's do for a character. A character a is equal to single quotes r. Okay, that's how you declare a single character. And if you want to display an array of character, we can call this name, square brackets is equal to double quotes precious ireo. Then you close all your statements with a semicolon. Okay, so that is how to declare variables in C. And now that we've declared our variables, you can understand now that there is something called format specifiers. So if we want to display the values of those variables, we use the format specifiers. Don't worry, I'm going to show you all this shortly. But to display character, for example, we are going to use the format specifier of %c. To display a string, we use %s. To display a float, we use %f. And an integer, %d. So we could do something quickly. Let's say printf, and I will say my name is, what is my name? Format specifier for string is s. My name is Precious, and I have, so I want to put float. I have so amount, $34.67. Okay, so to show that, we would say, according to the way they are arranged, the first one is name and the second one is z. Close the brackets, enter. So now let's print this out and see what happens on our terminal. So first we compile again and we run. And as you can see, it says my name is Precious and I have $34.66 because I didn't put a new line. That's why we have the other Precious here. Now that you understand format specifier, the next thing are data types. So there are a lot of data types in C. Okay? And these are every one of them. So the first one I've shown you is int with the size and the format specifier. All right? So now that you know the format specifier, you can also check the size of each data type. And how do we do that? We use size of. So let's check that out. So let's check the sizes of all the different data types that we have on this program. So we have 4 data types, right? Here currently. Let's check their sizes out. So to check the size of a data type, you use what we call size of. Okay? So since it is an integer, we are going to say %d. So size of char. Let's say size, let's start from the first one, size of int. Okay, then we do size of, open brackets, int. We want to check the size of int, close brackets, enter. So let's see if we can duplicate this quickly. Okay, I think I lost that. So let me just type that out quickly. So printf, then we say size of int. So I will leave you to do the rest. D, size of, so we are checking for int. And let's check for the next one. Let's check for character. Printf, size of, let's do float. Float is next. Okay. Good. So we say size of float. That's data type we are checking for. So I will just do these two. You can try the rest yourself. The same format, the same way I've done it. So let's compile. Let's run. And as you can see, it says size of int is 4. Size of float is 4. And if we check that out, is it correct? So size of int, it said at least 2, but usually 4. Can you see? And size of float is 4. So you see that we are on track. So you can do that for the different data types. So we have double, which is 8, and you use LF as its format specifier. Just check it out, and you can pause your screen and write all this down, or take a closer look at them to understand it properly. But to check their sizes, you just do it the way I've done in our program shortly. Now, the next thing is you may want to take user inputs. Okay? So how do you take user inputs? You can use the first one called, you can use scanf, you can use getchar, and you can use get. Okay? Or upside down, you can use Putchar, which is to, you use getchar to collect user input, you use Putchar to print user inputs, but these are for single character. Then you use scanf to collect a character before what's it called, before a space, and you use gets or fgets or puts to print out a character a long string of character that contains spaces. So let's try this 3 out. So I will clear. Then the first thing we do here is, let's edit. And we have a lot already, so I think we should delete some things. So let's delete. So first let's try getChar and Putchar. So to use getChar and Putchar, first you set a variable. We can declare x. Now that we've declared x, we can ask the person to enter a value. So we say enter a value. Then we set s to be that value. Okay, so getChar okay, then we can tell the person what they printed out using Putchar. Okay, that's Putchar. So you use Putchar to print out the result on the screen. So we can say printf, you entered, let's put a new line, and you use Putchar to do this. So the variable x, and let's run this script. Let's see what happens if it works properly. So we want to take input and output. Compile error. I use print instead of printf. So let's recompile. Successful. Clear. Let's run. Enter a value. I'll enter y, capital Y, and you see you entered capital Y. But this only works for a character. So next we are going to try scanf. Okay, so this only works for a character. Okay, next we are going to try scanf. So to use scanf, let's clear this. So we'll be using scanf now and printf, but this only works before any space character. So let's go back to our editor and try this out. So I'm going to turn this to an array so that we can take more values, and I would say 100. Okay, so now enter, let's say name, enter a name. And when you enter a name, we use the scanf to collect it. So you say scanf, format specifier for string. Okay, because we are collecting a string. And what are you collecting? We are collecting name. We've not set that variable name. So we have to put it here. We say name. Then after entering that, we can now go ahead and say, so what did the person enter? You entered, or we say your name is format specifier for string, and the value is name. So we don't need the Putchar at the bottom anymore. This is how scanf work. So we can save this, compile it, and run it. So let's run this. Enter a name. I enter Precious, and as you can see, your name is Precious. The third one, so let's try the puts and fgets. But you have to be warned, fgets, it's no longer necessary. So instead of fgets, instead of gets, you use fgets. Okay, fgets is to take the input, and puts is to print out the input to the outstream. Okay, so let's do this. So clear, And let's edit our file. So we will still work with the character name, but now we are going to use fgets. And the first thing it takes is the variable name, the strength, this length of the array, and the standard inputs, because that's what it is, std in. It's taking inputs. Then you can print it using this with printf, or we can also try it with the puts. Okay, so we can do that with puts. So what are we printing out? We are printing out name. But something else, let me do another put so that you can see that with puts you can print out other things. So I'm going to do something here. You can print anything with puts. So I will just say my name will be under. Okay, so new line character. So now I'm using fgets and puts. All right, now let's go back and test this out. So let's compile and let's run. Enter a name. I will enter my full name. And as you can see, your name is Precious Irieo. This is from printf. My name will be under. This is coming from puts, the first puts we did, and Precious Irieo is coming from the puts that we use to collect the variable name. So that is the three ways you can use to collect user input and print out outputs in C. Okay, now if you want to create a constant, this is the format. So you use the keyword const, the data type, then the variable name, but it should be in capital letter. So with constant, you cannot change the value of you can't change the value when you set it as a constant. Okay, take note. The value cannot be altered by the program during execution. All right. So the next thing I want to breeze on now is just for us to see what this is. So we have operators in C. We have arithmetic operators, increment and decrement, assignment, relational, logical, bitwise, comma, and size of operators. We've used size of already. So you can see arithmetic, this is it on your screen, plus, minus, multiplication, division, and modulus. Okay, assignment operators, same thing. So we're going to use this in subsequent videos, but for this video I just want you to see them and know that they exist. So, okay, arithmetic operators, assignment operators, these are what they look like. You can pause it and check them out. Relational operators, logical operators, relational operators, logical operators, bitwise operators, and something else you would like to understand is what we call math functions. So with math functions, you can carry out mathematical expressions in C. And let me show you something quickly. So I've typed out some math functions for you quickly so that you can see them in action. So in C, we have round that rounds up a number. You have to use math to import the math header before you can use the math function. So you have round, you have ceil, you have floor, square roots, power, absolute number, logarithm or log, sine, cos, and tan. So these are the math functions that you have in C. So guys, that is it in this video. I wanted it to be very short so that we can cover it quickly, but the most important thing is you already know now how to collect user input and output using getchar, putchar, scanf and printf, fgets and puts. And also, you also know about the data types, format specifiers, variables, and definitely how to compile a C program, which is very important. And we've also been able to create our first C program. So guys, I'll see you in the next one. Thank you.